Welcome back. So we are going to start today's lesson with what we have here: approximation and accuracy. This is the second topic. The first topic we are treating logarithms. Now let's deal with approximation and accuracy. Now in this class, let me state out my objectives. That is what I aim to achieve by the end of this topic. So by the end of the class, we should be able to obtain the following, and should be able to approximate numbers, should be able to, let me put it in way, at the end of the lessons. Should be able to, let's do the following. 1. Approximate numbers to the nearest 10, 100, 1,000, million, billion, and a trillion. That is objective number 1. Then objective number 2, we want to round off a given number to a specified number of decimal place or significant figure. Then objective 3, you can name them 1, 2, 3 if you want. Objective number 3, choose rounded numbers when making rough estimates. So calculations. Then objective number 4, we should understand the limits. The limits of accuracy. We should understand the limits of accuracy. The limits of which something is accurate, a figure or an expression is accurate. Then we should be able to solve problems of percentage error. At the end of these lessons of this particular topic, should be able to solve problems of percentage error. Solve problems of percentage error. Number 6, should be able to decide the degree of accuracy of results using tables and calculators. Choose to use a table as well as you can use a calculator. Then the 7th objective we intend to achieve here is this. Should be able to apply approximation to everyday life. To apply approximation to everyday life. So these are objectives clearly stated. The 7 objectives, they are the objectives that we aim to achieve by the end of these lessons. Now, let's talk about rounding off numbers. This is like a revision. Rounding off numbers. Now you see, we'll talk about approximation. We're talking about a rounded figure. That is not an exact value, but a value that roughly gives the entire results. For instance, we are talking about, let's say we have 837,515 naira. You can simply approximate it to be 837,000, ignoring the lesser figures. You can simply say it is roughly 800,000 or almost 850,000. You see, you tend to ignore other figures which happen to be less significant in a bit to give you an approximate value. So that is what approximation is about. Approximation helps us to understand the size of numbers easily. You understand? Let's take for instance that if the number of people and at a football match was 94,764. This is an insight from a book here, so I'm sharing it with you. A newspaper report will say 95,000. You see, it's an approximate value, right? Now, depending on the degree of accuracy required, this number can be rounded up as follows. So, the number, consider this for example, this number 94,764 is approximately 94,760 to the nearest 10. You see, this is approximately this. Now we are approximating to the nearest 10. We ignore this value of the units, which is 4. Remember the place values of numbers. This is unit, 10, 100, 1,000, tens of thousands. Now, if we are to approximate the same number to the nearest, let's say to the nearest 100, this will be similar to 94,800 to the nearest 100. I used to say we are approximating to the nearest 100, which is this. So we round off this 10. We round it off, it becomes 1 here. Add 1 to 7 becomes 8. Remember how we did it the last time? Let me just come back to it anyway. We said that when you're rounding off digits or figures, there is a rule. Any number from 0 to 4, you round it down. Any number or digits from 5 to 9, you round it up. Right? This digit, we are rounding up to the nearest 100 here. To round this number to the nearest 100, this is the 100. You highlight it like this. Now, the nearest digit at the right hand side is what you are going to round off. In this case, the nearest digit is 6. So you round it off. Rounding off means you should round up or down, depending on the digit. The digit is 6, which falls within this range of numbers to be rounded up. So, obviously, we round it up. and rounding it up becomes 1 here. 1 plus 7 is 8. So we have 948. Every other thing here should become 0. That is how you round off digits. So rounding to the nearest 10, we are at the nearest 100. We have 94800. Now let's go to the next one. This same number 947. Sorry, I wrote 977. It's 947. This same number 94,764. It's still approximately 95,000. To the nearest 1,000. Now, have you seen that the same number we are rounding up to different values depending on the degree of accuracy that we want? We want to round it up to the nearest 10. This is it. To the nearest 100. This is it. To the nearest 1,000. This is the value. But the implication is, in this case, to the nearest 1,000, we are ignoring the smaller values of hundreds, depending on the degree of accuracy that we want to achieve. So how did we get the 95,000? The same process I showed you earlier. We want to round up to the nearest 1,000. The 1,000 here happens to be this number 4, and you round off the digit that is at the right hand side. These digits at the right hand side happens to be 7, and you know when you have 7 falls within the range of numbers that need to be rounded up based on what I showed you here, right? Hence, we round up. And rounding up 7 will come 1 here. Add 1 to 4, it becomes 5. So that means you have 95. Every other thing becomes 0. And that's what we have here. That is how we round up to the nearest 1,000. So that is that. Now, if you want to add the numbers, you know that the digits 1, 2, 3, and 4. Let me write it down for you. Notes. Have it done as a note. We're rounding numbers. You have to note that the digit the digits 1, 2, 3, and 4 are rounded down. You rounded down. While the digits 5, 6, 7, 8, and then 9 are rounded up. You round it up. Now, let's take some examples. Example. Round off 8,539 to the nearest A, to the nearest 10, B, to the nearest 100, and C, to the nearest 1,000. Alright, so let's solve this. For the A, we are rounding 7,8,539 and 78,539 to the nearest 10. That is approximately what? Let's see. You know what I told you? This is units. 10, 100, 1,000, tens of thousands. No one used to teach us those days in primary school. Now, rounding to the nearest 10. it means you pick the digit under the place value of 10, which is 3. It's 3 that is having a place value of 10. Now, you highlight the digit that is nearest to it on the right hand side. That is the digit that you round off. And in this case, the digit is 9. Now, how do we round off 9? Do we round it up or down? Obviously, we round up 9 because it falls within the range of digits that should be rounded up. How do we round it up? It comes here, obtain a value. It becomes the value of 1 here. Add 1 to the 3, it becomes 4. So that means what we now have is 7, 8, 5, 4. The next digit is 0. So it means we have approximately 7, 8, 5, 4, 0. So what? So the nearest 10. So the nearest 10. See it, right? So it is as simple as that. Let's try this one. So we should round it off to the nearest to the nearest 100. Now the same thing we did in the first one, A, is what we're going to do in example B. Rounding off to the nearest 100, you look for the digits under the place value of 100. Notice this is units, 10, 100, 1,000, 10,000, right? Which digit is having a place value of 100? It is 5. From observation, you know. See 100 here. This is 5. That's step 1. Then, which digit is closer to it on the right hand side? It is 3. So it means we are going to round off 3. Now, the next step, does 3, do we round up 3 or round it down? How do we round it off? Of course, we don't round it up, we round it down. Why? Because it falls within the range of these numbers. 3 is within this range, right? So you round down 3. Now, rounding down 3 means it becomes 0. Are you there? It becomes 0, and every other thing here at the right hand side becomes 0. That is what it means to round down 3. And what we now have is 7, 8, 5, 0, 0. You see that, right? So let's write it down. So 8, 5, 0, 0 to the nearest what? 100. So that is how you round this number off to the nearest 100. And let's take this. The last one, let's round this up to the nearest, so 8539 to the nearest 1,000. Guess you know what to do now. This is units, 10, 100, 1,000. We highlight this. We are rounding to the nearest 1,000. Now this is 100. Select this. We have picked 1,000. The nearest digit on the right hand side, which is 5, is also round off. In this case, we are rounding it up. It becomes 1 here. 1 plus 8, 9. That means we have 9, 7. Every other thing becomes 0. So this is approximately 79,000. So the nearest what? To the nearest 1,000. You see it? So it is as simple as ABC. That very simple and interesting to know, right? Good. Now let's take more examples. Let's go further. I have any question, feel free to drop your questions in the comments section. More examples. It's a random 105 438 506 to the nearest 8,000 be million. So let's see. Solution. Let's solve this. If you have to round this to nearest 1,000, we know that this number is equal to what? So the nearest 1,000, this is units 10, 100, 1,000. We are rounding up to the nearest 1,000. That means we pick this one. Of course, we round up. And this automatically we have 9 here. If that thing is 0, right? So this is 105,439,000, isn't it? So the nearest 1,000 is what we have automatically. Can be we have 105,438,506 is equal to, if you have to round up to the nearest million, what was million here? You need 10, 100,000, 10,000, 100,000, million. See it, right? If you have to go further, this is 10 million, this is 100 million. Now this is million, you analyze this. It means you round off the nearest digit on the right hand side, which is 4. For 4, we don't round it up, rather we round it down because it's 4 within the range of digits to be rounded down. So when we round it down, it means both the 4 and every other digits on the right hand side obtains the value of 0. So that means we have 105, then every other thing is 0. How many? 1, 2, 3, 4, 5, 6. We have 6 zeros automatically. To the nearest what? To the nearest million. To the nearest million. So it is this simple, right? Good. Now we'll be dealing with decimal places. We'll deal with decimal places, which is the next we'll be dealing with. Now, decimal places. Now, when we talk about decimal places, we are referring to the number of places after the decimal point. I also say that after the decimal point, the number of digits we have. The decimal places refer to the number of places after the decimal points. For instance, the number 72.307, the number 72.307 is given to 3 decimal places. Look at 1, 2, 3. That means it's 3 decimal places. 1, 2, 3. You see? Now, see, it's given to 3 decimal places. And the first decimal place is 3, the second is 0, You can see this. First decimal place is 3, the second is 0, and the third is 7. So we can round up a number to a specific number of decimal places. Now, we'll take some examples to see how we round up numbers to decimal places. Let me state it down. Note this. A number can be rounded up to a specific number of decimal places as follows. Step 1. You look for the required decimal place you are rounding to. Then step 2, look at the next digit to the right, just as I told you before. Then step 3, if the digit is 5 or more, then round up. That is to say that you add 1 to the last decimal place you want. The last decimal place you want. If it is less than 5, then round down. Now you know what it means to round down, right? Less than 5, round down. I used to say that go that digit and the rest digits to the right hand side automatically become 0. Let's go to the next. We'll take more examples here. Here we have more examples to do it. Example. Let's take example. It's a round of 567.5684. I expect 567.5684. So the A, nearest whole number. B, 1 decimal point, decimal place. C, 2 decimal places, and D, 3 decimal places. So let's see how we solve this. Now we have 507.5684. Once we round out to the nearest whole number, when we talk about the whole numbers, these are the whole numbers here. These numbers are the left hand side of the decimal points. What you would have called a characteristic if it was a logarithm. So these are the whole numbers. So when I say to the nearest whole, it means this whole is the unit here. After the whole, what you have is decimal point. So it means you are rounding up to the nearest whole, you highlight 7, and as usual, the nearest number on the right, which happens to be 5, is what you will pick. So 5 needs to be rounded up. So you round it up, becomes 1 here. 1 plus 7 is 8. So you have 5, 6, 8. Right? So what it means is that to the nearest whole, this is approximately 568. You get the point? So the nearest whole number, this is what we have. Now, let's take the next example. So, if you have to round up to 1 decimal place, what is 1 decimal place? Approximately, this means let me cancel this. 567.5684. Approximately. Now, to the next 1 decimal place, this is 1 decimal place means after rounding up, there should be 1 number left at the decimal part. So we should have 1 decimal place. And it means we'll highlight this one. And then we'll pick the next one on the right, which is 6. We are rounding up 6. Of course, we don't round it down. So this becomes 6 here. We round it up 6. We have 1 plus 5 is 6. So this is approximately 567.6. See that? To the nearest, that is to 1 dp. That's our answer to 1 decimal place. You can say it's approximately this to 1 decimal place. It is that simple. Now I believe we should be able to do this next one. I'll just give you these 2 more examples so that you have many examples to guide you in your classwork and assignments. But you should be able to do them now. Yeah, by now you should have known that 567.5684, that is 567.5684, is approximately, now to 2 decimal places, so 1, 2, then this one we are rounding up. It is 567.57 to 2 dp, right? Yes. Now to 3 dp will be what? So 3 dp, this same number will be now 1, 2, 3, right? Let me bring it here. 1, 2, 3. These are all numbers. Now let's pick the decimal. 1, 2, 3. These are decimal places. So round up the next. 4, we round down 4 because it is less than 5. So we have 5, 6, 8, then 0. So we have is 507.568 to 3 dp. No need to write the 0, not necessary. Right. So let's take more examples. In this example, we'll round off a number to the nearest tens, hundreds, thousands. We'll be dealing with smaller figures now. Now, further examples. So round off and of 26.5274 to the nearest A, we have tenths. B, we have 100. C, we have thousands. Solution. Let's take A. Then 6.5274. So the nearest 10 is approximately what? Now we need to know something here. I'll talk about tenths. Notice the TH at the end of this 10. We have tenths, hundreds, thousands. Now these are very small place values of numbers compared to 10, 100, and 1,000. This is not 10, rather this is tenths. This is not 100, rather it is hundreds. And this is not 1,000, rather it is thousands. Tenths means an item is divided into 10 parts. So one part of it is what we call 1/10, otherwise known as tenth. Hundredths refers to 1 out of 100. Imagine dividing a loaf of bread into 100 parts, or slicing it into 100 parts, 100 pieces, or 100 slices. Each slice will be referred to as 1/100th of the entire loaf, otherwise known as hundredths of the entire loaf. We have a similar explanation for thousands. If an item is shared into 1,000 parts, one part of it is known as 1,000th or thousandth. So you see how small these place values are. They are different from the 10, 100, and 1,000 that you know. Now, let's come back here. It's a round of 26.5274 to the nearest tens, hundreds, and thousands. Now, these tens, hundreds, thousands, millions, and all of that, they fall at the right-hand side of the decimal point. See that? So, that's where we have smaller place values. How do you assign them? This is tenths, this is hundreds, this is thousands, right? Say millions, and so on. The tenths appears immediately after the decimal point, and obviously the figure, the digits at the left-hand side before you get it to the tens is the units. The digits having the place value of the units. So the unit is having a higher place value than the tenth. Likewise, the tenth is having a higher place value than the hundredths. Hundredths is having a higher place value than thousands. But 10 is greater than unit, 100 is greater than 10. This is the order. Let me write it somewhere for you. This is the order. The order is, we have unit, 10, 100, 1,000, and so on. Then after the decimal point, that's after you need the unit to get the decimal point, we start having tens, that is 1/10, hundreds, thousands, and so on and so forth. So, let's take this. Now I think we should round up to the nearest tenth. The nearest tenth is what? From observation, this is tenth. As usual, you round off the digit at the right-hand side of that particular tenth. The digit happens to be 2. 2 is to be rounded down. You know why we are rounding down. So when we round down, maybe that thing here is 0. So we have 26 points. Say to the nearest tenth, we have 26.5 to the nearest tenth. You see how simple it is. Now let's take this one. If you have to round off to the nearest hundred, this 26.5274 were approximately, this is tenth, hundred. So we are rounding off this, and it means to round it up, right? It's approximately 26.527 to the nearest hundreds. Notice my pronunciation, hundreds. That sound at the end. So rounding up to the nearest thousands, you should know how it's gonna be. You already know by now. 26.5274 is rounded up to nearest, let's see, tenths, hundreds, thousands, right? So we'll round off 4, which is going to be rounded down. So automatically we have 26.527 tenths, hundreds. Sorry, this was supposed to be 20. This other one, rounding to the nearest, we have to round up to the nearest hundred, right? This is tenth, hundred. So we'll round this one up. It becomes 1 here. So we have 26.53. So this one should be 53. That's the correct answer. To the nearest hundred. Now this one to the nearest thousands. This is tenth, hundred, thousands. We'll round this one up. Rounding it up, we'll round it down. So we have 26.527. Remember, this is the thousands here. So we don't need this one. We have 26.527 to the nearest thousands. Wow, simple, isn't it? Yeah. As ABC. By the way, very interesting. I guess it is interesting to you. Or just in case maths is to be boring to you, you don't like maths. It is possible that it's getting interesting to you now. The way details have been explained. You have problems, you need clarifications. Don't hesitate to drop your comments, your questions at the comment section. Now, you realize that to round the decimal number to the nearest tens, hundreds, and thousands is same as rounding to 1 decimal place, 2 decimal place, 3 decimal place, 4 decimal place, and so on and so forth. Right? So there's no big difference here. Let's take further examples. This time around, we'll be dealing with some kind of units, measures. For example, further examples. You say round off. Or let's say round 25.6135 kg, that's kilogram, to the nearest grams. So round off 25.6135 kilogram to the nearest gram. This is 5. How do we do that? Now you need to know something here. Now, if you say round up to the nearest gram, we need to know the similarity or the relationship between kilograms and grams. For every 1 kilogram, we have 1,000 grams. That is to say that 1,000 grams make 1 kilogram. Now, noting this, let's write it down. 1,000 grams is equal to 1 kilogram. That is a fact we need to know. And that means that that implies that 1 kilogram is another way of saying that 1 kilogram, let me write it like this. 1 kilogram is equal, let me write it like this. Okay, 1 gram is a way of saying that 1 gram, that implies that 1 gram is equal to a kilogram divided by 1,000. That is 1 over 1,000, or 1,000, or you can say thousandths of a kilogram. You see the relationship, right? You can either say 1,000 grams is equal to 1 kilogram, or you can say 1 gram is a thousandth of 1 kilogram. Right. Now, to round this digit to the nearest gram is like rounding up to 3 decimal places. Now we have if we have this, you will say that from observation you will notice that 25.6135 kilogram is equivalent to 25.614 kilogram. So this should be gram to the nearest gram. You see that? It is as simple as that. Well, just in case this one is not clear to you, let me try to put it in another form for you, which is likely going to be well dated and more well clearly explained. You see, we should round off 25.6135 kilograms to the nearest gram. And we note that 1,000 grams is equal to 1 kilogram, because 1 kilogram is 1,000 times 1 gram. Otherwise, you can state it like this: 1 gram is 1,000th of 1 kilogram. That is a kilogram divided into 1,000 parts. 1 unit of each of those divisions is called a gram. Now, noting this, you can use this. Just leave this first. You can use this. 1,000 grams equal to 1 kilogram. That means 25.6135 kilogram will be equal to how many grams? So let's see. How do you do this calculation? There's a common way you can do this. You can do this. Right? If you do this, we have S times 1 equal to is this gonna work? 1,000 times 25 points. Okay, this is not going to be helpful. This will look more complex. So we'll stick to the first method that I've given to you. You just have to take note of these facts, and then you should know that to round up to the nearest gram simply means you round up to 3 decimal places. Remember, 1 gram is 1,000 grams, and 1 kilogram is 1,000 grams, which means 1 gram is 1,000th of kilogram. Otherwise, you can write it like this. It's like saying 1 gram equal to 0.001 kilogram. Idea. So if you want to round off to the nearest gram, Just round up to the nearest to 3 decimal places. And that's how you do it. That's the logic. So if you do that, obviously in this case, 25.6135 round up to these 3 decimal places. 613, you highlight 5 to be rounded up, and you have a 25.614 kilogram to the nearest gram. Now, you don't be surprised that our answer is in kilogram, despite that we are rounding it to the nearest gram. We are not expected to express in grams. We are expected to express in kilogram, but we are considering rounding it up to the nearest gram. So that's the logic here. When estimate, we will treat significant figures. That will be the next subtopic. Significant figures. Do well to make sure that you do not miss the next class. Significant figures. That's what we're going to deal with in our next video. So thank you all for watching. I remain Jumbo Lucky Wajirogene. God bless you. Expect to see you in the next video.